what we'll do is, we'll do a poll. Now, my professor, Sir Arnold Wolfenberg, who's the 14th Astronomer Royal, he always does this on cruise ships, and I've followed him through Fred Olsen. So how do you think there's any life of any form? It could be, you know, sludge, it could be amoeba, it could be fungi. Who thinks there's some form of life anywhere in the galaxy? All right, who thinks not? Just about 5 or 6 out of 100. 5%. Okay, next. How many think there's intelligent life besides us? Besides us? Half. Who says no?
How do you define intelligence?
Someone that can solve the Rubik's Cube. What is he saying? What is Rubik's Cube? Next. Who thinks we are unique in the galaxy? Oh, quite a few. So Arnold, 30%. Who thinks we are unique in the whole universe? There's no one like us in the whole universe. Still, we're looking at numbers. We're still looking at about 6, 7, 8%. Right, we'll do this at the end and we'll see if we changed your mind. Interesting. Right, first of all, you've got to get an understanding. Some of us are geological people. Some of us are friends of the Royal Astronomical Society, the oldest astronomical society in the world. 1820. So, we have 100 billion stars and in a galaxy, and there are approximately 100 billion galaxies, and my students are sitting in the middle, and they'll know that 10 to the power 11 times 10 to the power 11 is 10 to the power 22! 22, madam! So we're looking at what? 10,000 million trillion stars. Now, of course, that is a number which is bigger than the number of years that the Earth has been around, 4.5 billion. I won't get you to walk to John O'Groats anymore. But the fact is that there are more stars, than there are grains of sand in all our beaches. I worked this out yesterday. It was about 10 to the 20. And for those of you who don't know what a beach is, I mean, I come from Whitstable and I have no idea what a beach looks like. I've got one here. That was my man Friday walking away from me. Is that one of the beaches you've been to? Have you made a sand castle?
Some of the beaches walked along.
Oh yes, the sun of the beach, yes. Sun of the beach. Oh my goodness, you said something really bad. Now the fact is, if you take a cubic metre of sand, each grain is roughly a millimetre, you've got 1,000 times 1,000 times 1,000, there's 1 billion grains. But just think of all the beaches, there are more stars in the universe, the visible universe that we can detect, than there are grains of sand in all the beaches on the Earth. And to prove it, I want you now to do a thought experiment. What did Einstein do very well for many years? He did thought experiments. So all of you now, pick up one of those grains of sand that you like and hold it up against the sky. Are you all doing that now? There we are. Small patch of sky. Would you agree that's a small patch of sky? Now the moon is half a degree across. Yeah? Half a degree by half a degree is 1/4 of a square degree. But that patch of sky that was looked at by the Hubble Space Telescope way back in 2004, many, many hours of counting photons, and each one of those things is a galaxy. So, this is what astronomers do. 1, 2, 3, 4, 5, 6, 7, 10,000. How many grains of sand would cover the whole 41,000 square degrees? Quick calculation, sir. 100 billion! Excellent student, excellent student. So, and then we counted the stars in a galaxy. Herschel started the job, we finished it off. And the fact is that each one of those beautiful little galaxies, some of them are spiral, some of them are elliptical, you name it, we've got it. They are lots of stars. So there are more stars, sir, than grains of sand. Deep philosophical thoughts. And there is a proof that when our friend Galileo, were you Galileo a few minutes ago?
You were 1643.
Yeah. What? Yes, he died. No, he died in 1642. No, he did a lot of work in 1609, 1610, 1611. So, Galileo, what have you found? I have found, sorry about the Italian accent, I have found lots of stars that no human has ever seen before. And you start counting those stars, and unfortunately most of the galaxy we see has dust. Now, you don't get much dust. You get one grain of dust in a room this size. And then the next room, you get another grain of dust. But you look at light years. You look at 10 trillion kilometers, and you keep adding it up. There's an awful lot of dust. It's like being in a fog, madam. You are in a fog. Can you see me? You can't see me because of all these particles scattering light. And so by the time you try to get to the centre of the galaxy, 30,000 light years away, you cannot see the centre of the galaxy. And I know what you're going to say. How do you know what's in there? Well, we use radio waves, sir. We use microwaves, sir. We are using electromagnetic spectrum from radio up to gamma rays. And what penetrates the fog of dust? Radio astronomy. Carl Jansky, 1931, great man. So here's another picture. Perhaps I should take that picture out. There's too many pictures of our galaxy. What's our galaxy called? The Milky Way. The sweet you cannot eat between meals without ruining your appetite. There's an advert there. Now, outside our galaxy, we certainly found in 1923 Edwin Hubble. Anyone heard of Edwin Hubble? He was an ex-boxer. Can you imagine that? But he turned to astronomy. I'm a weightlifter, by the way. If you're interested in weightlifting, you can see some of my weightlifting videos on YouTube. It's true. Who doubts me? I came 5th in the European Championships. Oh, ye of little faith. Now, around us, and I've just read an astronomy magazine on the train, there's now 63. It used to be when I was a student of astronomy, 25. But the most famous one, of course, is the Andromeda Galaxy, which, by the way, is coming towards us. It's one of the few galaxies, when you observe the light, it doesn't have a red shift, which means going away. It has a blue shift, which is coming towards us at about 200 kilometers per second, and will hit us in the next 3 billion years.
Are we going towards it?
It's all relative, so it's all relative. Right. So we managed to have this galaxy coming towards us, and if you want to see one of my other talks, like How Will the World End, I will tell you about Andromeda hitting us in 3 billion years' time. You like that? So, and then we go out and out. We are part of the Virgo supercluster, and there's clusters, and then there's superclusters, and there's great big voids out there. We've seen huge amounts of space where there's no galaxies whatsoever. Right, now the question we've got to ask ourselves is, how many civilizations are there? Well, first of all, you've got to know how many stars there are. I know what you're going to say, 100 billion. Some estimates put it at 200 billion. We've got to know what sort of conditions. It seems that you need water, but has anyone in this room heard of extremophiles? Yeah. Good, there's a lot of nodding here. Yes, yes, madam. Thank you very much. Extremophiles are creatures that can withstand terrible conditions that we cannot stand. I mean, you live in Camden, don't you, sir? I do. So I find too much alcohol is a bit extreme myself. But some can actually withstand 2 molar salt solution, like the Dead Sea. Some can withstand minus 50 degrees Celsius in the Antarctic. Some conditions like 200 degrees Celsius near these fumaroles, these huge volcanoes. Yeah? So you can withstand between minus 50 and 200 degrees C. You can withstand fantastic acidic conditions and very alkaline conditions. Perhaps out there's like, but we think you need water. You certainly need energy, and you need a star that produces energy, not for 1 million years. The brightest supergiants will blow up within 1 million years of being born. So we don't want a planet going around a supergiant that will blow up, because life won't get started. How long, sir, did it take for life to get started on our newly formed Earth? Did I hear 700 million? Well, I've heard 700 million. You've heard 300 million? I've heard 700 million years. So, one of my lecturer friends is Dr. Francisco Diego from University College London, and he'll have a length of string 13.8 meters long. And each meter is 1 billion years. And so, the universe started in a big bang. 9 billion years our sun and solar system was formed. And then just 70 centimeters you could start life. And then we come along. And this is one of my favorite things, and I'm pinching it from Francisco. I'm pinching it now. You see that? You see that thin paper that can give you a nasty cut? On one side it's got Cro-Magnon man, big hairy ape. Yeah? And on the other side it's got Albert Einstein. Why? Because that's 100,000 years. That's the difference between Cro-Magnon man, what is that? That's the moon. And what's that? Einstein, General Theory of Relativity, 1950. So we've come a long way since Cro-Magnon. Anyone Cro-Magnon here? Okay. Okay, I don't want to put people down. So, for the last 53 years, we've been trying to listen out to them. Not yet. We've tried to communicate with them. Even I, and I'll tell you the story because it will make you laugh, tried to communicate with the aliens, but I haven't heard anything back since then. So we've got to know this. And everyone has heard of the Frank Drake equation. Put your hands up if you've never heard of Frank Drake. Good. Okay, Frank Drake was a professor, and in 1960 he came up with one of the most famous equations. I'm trying to tell my students in the middle row what an equation is. It has an equal sign in it. And the stuff on the left-hand side should equal the stuff on the right. And the units, remember the SI units. Well, it's dead easy, it's just a pure number. And so we go through it very slowly. Yeah. Number of intelligent civilizations. This will be a number between 0 and God knows. If it's 0, what does it mean? It means we're the only ones. We're the only ones. If it's thousands, God help us, they might be landing as we speak in the Geological Society. Okay, so we need to know how many stars. Well, it's between 100 and 200 billion. Yeah? And we'll take the worst case scenario and the best case scenario. And we'll put the numbers in. And then FB is the fraction of stars that have planets. Recently, Kepler has been looking at over 100,000 stars every 30 minutes, waiting for one of these planets to go in front. And what happens when a planet goes in front of a star? It dims very slightly. And we've discovered 992 planets. So a lot of stars seem to have planets. And then, how many planets can support life? Well, the Earth can. Mars, possibly billions of years ago. Then, how many planets develop life? Well, we develop life. After 700 million years, we developed life. And for 2 billion years, do you know what that life did to the atmosphere of our planet? They were really nice. They actually turned the amount of oxygen from less than 1%. Can we breathe 1% atmosphere oxygen? No, to 20%. So thank you, bacteria, for living for 2 billion years and doing something to our atmosphere. And then finally, we've been going for billions of years, millions of years, billions of years. And when did we develop intelligence? We have in our lecture theatre an artist, Anastasia. When did humans started painting the walls?
Sensation time.
Yes, 40, 50,000 years ago, Homo sapiens. Interesting. And then finally, the fact that you are intelligent, have you invented radio? Have we got a Marconi amongst us who can transmit radio waves? Does anyone actually listen to ITV? You are intelligent. But the fact is that we have been broadcasting Coronation Street for the last 53 years. At the same time as we've been listening out for intelligent beings, I think. And finally, you know we are intelligent, and you know America and Russia have about 50,000 atomic bombs. We have been waiting for the war that would destroy us all. But we know that we're intelligent and we will not destroy ourselves because of this idea of MAD. What does MAD stand for? Mutually assured destruction. You blow us up, I'll blow you up. And I'll put on a Cockney accent for that sort of thing. Okay. Now, I've done the math. I've done the mathematics. So you've got, the worst case scenario, 100 billion, 200 billion. How many stars have planets? 1 in 10. Most have. How many Earth-like planets? About 1 in 10. Well, out of 8 planets, we've got the Earth. Yeah? How many can produce life? I think most planets, if they've got water, if they can go around the star and not have enormous changes in variability of light output. And our sun has grown gradually over the last 4 billion years, but gradually. Does it vary in brightness? Who's heard of the 11-year sunspot cycle? It does vary slightly. You get different tree rings, don't you? So, there's this cycle, but it's only about 1 part in 1,000. I hope you're making notes, sir. Yes. So, you need that sort of long time. And finally, and this must be one of the hardest ones, how many will communicate? So you've gone up to Marconi and then you wipe yourself out. You've gone up to landing on the moon and then you wipe yourself out. You've got yourself landing on Triton and all these other moons of the solar system, and you're building bases, and you're just about to build a spaceship to go to the stars, when there was a war, and you wipe yourself out. So you do want the civilization to communicate, possibly through microwaves. Why microwaves? Have they all got mobile phones? Well, they can, as I said, radio waves, microwaves, they can pass through the galaxy, while light is stopped by about 3,000 light years worth of dust. So you won't be doing this with your lasers. So we've got that. Now, here we have it, folks. We are either unique, or there's 45,000 civilizations, even as I speak, ready to communicate with us. Are you listening? Madam, of course they speak English. It is a universal language. If you watch Star Trek, what do they speak? Indeed, one American senator said, if English was good enough for Jesus, he's good enough for us. Who am I to say English? Now, just before coming on the train, I went to www.exoplanet.eu. Now, I think EU is Europe, so I know some of you don't like Europe, but there are some good things coming out of Europe. And this website tells me every few weeks the updated. Oh, hold on, I'm just getting something through at the moment. Sorry, you've just found 8 more planets. A big hand. 1,000 planets, ladies and gentlemen. We've just had 1,000 planets that have been discovered. Now, I like Blind 581 because it's not that far away. Some of these so-called planets that are like the Earth are 2,700 light years away. And madam, do you know what a light year is? Well, light travels very fast, as you probably can guess. And I can go around the Earth 7 times in a second. Some of my students are from China, which means I can go to China in a 14th of a second. They take 14 hours. You can go to the moon in 1.3 seconds. You can go to Pluto in 6 hours. But to go to the nearest star is 4.25 light years away, let's say. And a light year is 40 million kilometers. So, I think 20 light years is a bit of a stroll compared to some of these planets that are 2,700 light years away. And here's an artist's impression. I don't know what they drink, these artists, but they obviously think that some of these planets, this is 600 light years away. So, this planet, and I'll just explain this because I've got a good analogy, I like this analogy. You know, if you transit, Venus transits the sun, and of course, it will slightly dim the sun. So, a planet will dim the star by about 1 part in 100,000. Now, I don't know if anyone knows Canterbury. Anyone knows Canterbury? There's about 50, 60,000 homes, and some of them have cats. And in the dark, you're flying on one of your aeroplanes, and you look down, and somebody opens the door. What happens? The kitchen light comes on. And suddenly there's an extra light on. And they put the cat out, and they close the door. What happens then, sir? What happens then when you close the door, the kitchen door? The light goes out. And that's one light in 100,000, and we can detect that. Photometry at its best. Photometry, measuring photons light. But of course, you go around like this, yeah, and you think you detected a slight dip for a few hours. But was it right? Was it noise? And then, obviously, planets like the Earth take about a year. So 1 year later, you see another dip. And you need about 2 or possibly 3 transits to say, definitely a planet, definitely another piece of dirt or something. And so, that is Kepler 22. Here's some latest results. We've got 3,500 plus candidates. And unfortunately, what happened to poor Kepler in the last 4 months? It stopped working. Don't worry, they'll put some other satellites up very soon. But the fact is, they will spend years analysing that data. And we believe that 90% of those 3,000 candidates will be confirmed. And from that, you do your mathematics, and you'll say there'll be 17 billion planets like the Earth. not all in the habitable zone. The habitable zone is not too hot, not too cold, but at just the right zone. And so you would like later on, and again I was reading a magazine, astronomy magazine on the train, they want to put up into space a satellite that will actually image. This is just an indirect way, isn't it? You see it dim down. Actually image the planet right next to a star. It's like a firefly and a searchlight. The difference in contrast is 1,000,000 to 1 in the infrared, 1,000,000,000 to 1 at light. So you've got to get rid of all that light and somehow just focus on the tiny little planet. And then if you can get a few photons, you can split the light up. And what did Huggins do in 1860? He split the light off of Aldebaran, and he found calcium, and he found hydrogen, and he found all these elements. And so if we do spectroscopy, we can find out what the atmosphere of the planet is. And what happens if there's oxygen? What happens if there's ozone? What happens if there's methane? Put your hands up if you give off methane gas. You do, sir, and madam, sir. And those carrots, we like to be sick. Yes, they give off an awful lot. Now, my wife, who's a literary person, said, why can't we put bags around their backsides? So you say, she's not a scientist, she's not a scientist. She's a writer, Linda M. James. Okay, let's move on. So we've got the fact that Kepler still has results to be analysed over the next, 5, 10, 15 years. This is one of the most complicated slides I've ever seen, so we'll just go past here. But there are at least 3 ways of finding a satellite. Yeah? There's photometry, which is examining the light. Also, you know the Earth is about 333,000 times less massive than the Sun. You knew that, didn't you? Yes. Natalia, is it Natalia? No. Oh, who's the worst people too? Oh, no, that's an alien broadcasting, all right. Well, the star will have a slight wobble. So there's these dynamical effects. Now, when I was a student at University College London, just give them a plug, University College London, we tried to measure whether stars coming towards us or away from you. We looked at Saturn. This is a third-year project, and you look to see if that's a blue shift coming towards you and a red shift. And I worked out the period of Saturn, and I knew it was 9.5 hours, and I got 10 hours, which meant I got a really good practical result. They can now look at a radial velocity of 51 centimeters per second. Now, I'm going to come at you really fast. Watch this. Can you tell the blue shift? Now I'm coming away from you. Can you tell the red shift? How do they do that? I cannot understand. You see, I think what happens is you go to university and you learn lots of things, and then you forget everything. That's education. And now I'm so adrift of what's happening, I just don't understand myself. But so there was Kepler, and it did last the presumed 4 years, but they were hoping to extend it for another 3 years, but unfortunately the wheels came off the wagon. You need these rotational wheels to be able to accurately point. And I explained to my students a few days ago what an arc second is. An arc second is me holding up a 5p coin at 2 kilometres. Now, I used to do rifle shooting. I was the best at UCL, actually. So I would focus on that man's ear and then move to the right ear. That's probably 1 or 2 degrees. But can you imagine looking at a 5p coin and moving your sights just from one side of the coin to the other? That's an arc second. So you have to point that telescope less than an arc second accuracy. Absolutely amazing. And I said, it looks at these stars for 30 minutes, but in the future we will be sending up satellites that will be able to actually observe the exoplanet. Exo, outside our solar system, exoplanet. Right, now then, the smallest planets. A lot of the planets they've discovered through Kepler are enormous. You think Jupiter's big. You could fit 1,000 Earths into Jupiter. They will make Jupiter look small. And of course, some of them are very close to the star itself. And so what is the surface temperature? The surface temperature, what is this room temperature? 20 degrees Celsius? What's the average on the planet Earth? Who's from the Geological Society? I know, I should talk to the Meteorological Society, shouldn't I? I think it's about 15 degrees Celsius. But some of these planets are 1,000 or 2,000 degrees Celsius. So there'll be no life on them whatsoever. But the smallest planets KOI stands for Kepler Object of Interest. So they give it a designation, and then they call it Kepler 69, Kepler 62, and so on. So here we have some of the smallest planets, and there's about, let me think if I can remember rightly, 20 exoplanets about the size of the Earth. Well, let's move on. But of course, you can have an exoplanet. If it's too close to the star, it's too hot. If it's too far away. And of course, you also have to realise that not every star is like the sun. Now, who thinks, or who has read in books, that the sun is an average star? Well, they're wrong.
Small.
Well, no. 3% of stars are more massive than the sun. I want you to think of a pyramid. So these are the most massive stars, very rare, Wolf-Rayets, say 100 times more massive than the sun. They'll blow up as supernova, and then less mass, our sun, and then all the rest, 97%, have a mass less than the sun. So a lot of stars are called red dwarfs, named after the famous TV series, and there's Gliese 5A1. And the smallest mass stars are about 80 times the mass of Jupiter. So some people say Jupiter is a failed star. No, it's not, it's a planet. You need 80 of them before the central core temperature is hot enough to be a star. A star is born when the core is producing nuclear fusion energy. Jupiter is hot, it's 30,000 degrees Celsius in the core, but it's not hot enough to produce nuclear fusion. And you've got to, you've got to be right in this habitable zone. But it depends on the size of the star. So the smaller mass star, the closer you are. Now, for those of you who don't know, 1 AU means 1 astronomical unit, the distance between the sun and the Earth at the moment. Now, some of these numbers are a tenth. So Mercury is about here in our solar system, 0.3. So you could be closer to a star, this one, than Mercury is. Now Mercury is quite close to the sun, and it's so hot, it's about 400 degrees Celsius. But which is the hottest planet in the solar system? Venus, 460. And that's because it's 96% carbon dioxide. And do you want to play with the Earth's atmosphere? Do you think global warming is an important subject for us to be thinking about? Well, that's another talk. I'll do that another time. So, ladies and gentlemen, the habitable zone. Now, this is sad. In 2007, because of the banking crisis caused by, it starts with a B, bankers, good. Can you say that? The fact is, we were going to launch spacecraft that would actually be able to analyse the atmospheres of these exoplanets. And there wasn't just one idea. There was the Americans' terrestrial planet finder, and there was ESA's Darwin, named after yes, that's right. So Charles Darwin, excellent. So you've got the idea, but they never pull their resources together, and both ideas have been chucked out. However, just reading this magazine on the train coming up here, they will be sending up satellites up there, sensitive enough in the next 8 or 9 years, that will be able to analyse the radiation from an exoplanet directly. And we'll be able to see. Now, if you produce life, I mean, obviously, what do plants do? They're taking carbon dioxide and give out oxygen. We breathe out carbon dioxide. We give off methane gas. Rice paddy fields give off meat. You know, there are signatures. Ozone is a signature as well. And so if we find this, we can't say there is definitely life on that planet, but by goodness, there is a good chance that there is. There is a good chance. And then we could send out radio waves or Coronation Street. Okay. So Darwin also had the same idea, and these are the gases that they would like to detect using spectroscopy. One of my favourite stories in astronomy books is there was a great French philosopher, so famous I can't remember his name, but somebody here will probably know his name. And he said, philosophically, there will be some problems we will never ever be able to solve. For example, we will never ever be able to go to the stars, and therefore we will never ever be able to detect what the stars are made of. 4 years later, Bunsen and Kirchhoff, I discovered spectroscopy. Huggins, the English scientist, I have looked at Aldebaran, the bright star in Taurus and Ball. So, I'm very sorry, Mr. French philosopher, you were wrong. Right. These large telescopes, this one is just about finished, 66 telescopes. These are the most sensitive radio telescopes in the world. There's going to be ALMA, there's going to be the microwave band, the square kilometre array in the next 6-7 years. And that will be incredibly sensitive, and it will be looking back at radio waves that came from the first galaxies. When the universe was born, it was incredibly hot and very, very dense. And then it reached a point at 380,000 years when the light was able to escape. No longer was the universe opaque, it managed to escape, and the last photons have reached us after 13.8 billion years. The universe has expanded, in fact it's accelerated since then. And we are able to look back to that point. But if you can use this star telescope, you'll be able to look at the very first galaxies forming. You'll be able to look at planets forming in solar systems. So there's that one. There's one of the actual ones. I've never obviously been there. Unfortunately, I did a PhD in astronomy, and I've never actually been to an observatory. I must have said something wrong to somebody. I don't know what. Still. However, that is a very interesting one. That's appeared in various films, hasn't it? Yeah, well, they actually sent out a message in 1974 to some stars nearby. But we, as I said, we haven't actually had any messages back, so we'll see one day if we do. But that is a very sensitive radio telescope. Now, again, we're going to have to do the mathematics. Now, I've pinched this. I've still all my ideas from great people. Professor Barry Jones, I work with slightly on Open University courses. Professor Jones came and talked to us about extraterrestrials. Now, how many stars should we look at with our radio telescopes? Well, obviously, you should look at solar-type stars. So I picked a number at random, 10 million. There are 10 million nearby stars that are like the Sun, a G2 dwarf, let's say. Now, I don't know, have you ever tuned in to something? What's your favourite radio program? Radio 3. Is that about 92 megahertz, sir? Yes. But what happens if you tune in at 93.5 megahertz, sir? What would you get? Yes, or Radio 4, which is what I listen to. So you've got to get the right channel. And if you're listening to ET, you've got to get the right channel. How many channels? Well, in the microwave waveband, you'd have to have a very narrow bandwidth. Otherwise, all this energy will be dissipated if you try to use too large a bandwidth. And so, as I wrote in my beautiful slide, between 60 megahertz at one part of the microwave spectrum to the other, there'll be about 600 million channels to tune in. So, I'm going to pick a star, this man here. And I'm just going through the 600 million channels. Well, that's the first night of observations. Shall we try again? Of course, when I'm going through these channels, the one he picks to speak to me will be tomorrow night, won't it? And I'll have gone past it. So, there is this three-dimensional graph. You can either look at this star or this star. You can look at this channel or this channel. And of course, I'm alive now. Did you know that this civilization died 1 billion years ago because of atomic warfare? Really sorry about that, sir. So, but we have at hand one of the entrepreneurs, I don't know who, somebody who's as clever as Bill Gates and all of these multi-millionaires.
Alan?
Was it Alan? Thank you. Let's come up with the Allen telescope array. And of course, that is a small array. It's not too expensive, 350 dishes, but it's able to look at simultaneously 1 million different stars. It's so clever. So I think we could possibly reduce the odds by using technology that has been developed in the last 5 or 10 years. Now, I just put this in for fun because Sir Arnold Wolfendale does this when he does his talk. Has anyone heard of ALH 84001? Yes, yes. Anyone else? Who hasn't? Right. I can't believe this, but some asteroid hit Mars about 15.5 million years ago. It produces a lot of rock. Some of it might escape Mars's gravitational field. It then floats around the solar system for a few million years, and it lands in the Antarctic, where we pick it up, cut it up into little pieces, and he explains that if you're a scientist and you're looking for money from the government, the United States government, What do you think you might find inside this rock? So you get lots of money from Obama. It's fossilised bacteria, sir. I think I'm going to have to give you a grant for several years to actually investigate this rock. Anyway, they've investigated the rock, and it's probably somebody's dirty fingerprint. Yes. So, what a shame. But I like the idea that there might have been life on Mars. So, let's go back to doing the science. So, we managed to get to the fact. But as I said to this person over here, if you are thinking about listening to a civilization or broadcasting to the civilization, we've lasted, how long is it since Marconi sent the radio waves to America? Was it 1913? So it's 100 years. Do you think we'll last another 100 years? Think about Syria, think about Syria. Concentrate now. Do you think we'll last another 100 years? 200? Yeah. What were we doing 1,000 years ago? I could get an archery bow and I could possibly fire 3 or 4 arrows a minute and puncture 3 or 4 people. And now I've got a 50 megaton device. So we can do that in 1,000 years. Do you think we can actually last another 1,000 years? Just think about that. Okay? Okay. Well, I said that we might last 100,000 years. But of course, for the lifetime of life, it's nothing. It's 0.003%. So here's the final sum. What are the chances of today listening to extraterrestrials? First of all, we're going to examine 10 million stars. Now, I know what you're going to say. Let's broaden it out. But let's just start with the first 10 million stars. We've got to listen to at least 60 million channels. And the fact that we're listening now and not a billion years ago or a million years ago, we've got about 30,000 to 1's chance that we actually got the right civilization now. And so the chances are that, which is less than winning the lottery. By the way, has anyone won the lottery? Oh. All right. Does anyone know anyone who won the lottery, the big one?
I know someone who bought a house from a man who had one.
Oh, well, that's close. Shook your hands. Right, just telling you a little story here. I have a friend in America who's a musician, head of music he was, and I shook his hand. He knew a guy from Austria called Arnold. Anyone heard of Arnold Schwarzenegger?
Yeah.
He must have held the hand of the President of the United States. And the President of the United States must have held the hand of the President of China. 1, 2, 3, 4 away from the President of China. Okay, so what we can do now, and you kindly help me out on the Allen list, thank you. I did a lot of homework for this, I'll tell you this now. We can now look at millions of channels, and we can look at many thousands of planets, and we can do this over the next 10, 20, 100 years. And so the chances are just 100 billion to 1. But ladies and gentlemen, can I just point out, if we don't listen, what are the chances then? Zero. So please, put some money into science. Listen out for these aliens. They could tell us something. You know, how to cook an egg or something. I don't know. So, now, we have sent things out there for them to actually come and find us. Now, I know Professor Hawkins doesn't like the idea, but we sent 4 probes called Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and one of them is now 3 times further out than Pluto. It's more than 120 astronomical units away. That's 125. One of them is still in contact. So here's a nice picture I stole. By the way, I thank Google for this presentation, for letting me use their slides. So here we have, and it's just about to break through into interstellar space. But you know how long it will take to reach the nearest star, traveling at 40, 50 kilometers per second? Many thousands of years. Many thousands of years. 100,000 years to the nearest star. Although, when I wrote that slide, I wrote 40,000, so I'm wondering if I made a mistake, or the people that were trying to calculate the speed. But on it is Bach. Now, one of the great people of all time was Carl Sagan. You admit that, don't you? Carl Sagan. And he was once asked, what should we put on this disc, this CD? He says, Johann Sebastian Bach. They never thought that would be ghostly. And he's my favourite composer. And there is a model of the hydrogen atom. This is how far away we are from the nearest pulsars. And we've got another one, another gold plaque. And this is a bit rude. Can my students please close their eyes, please, for a few seconds? That's good. Well done, Darren. I know you haven't seen this before. But, we have here a picture of a man and a woman. But as Professor Hawkins, I think, has intimated, what would you see? What would you see if you were an alien and I took you to the planet Earth for the first time and I showed you a field full of cows? What would you think? All right, forget about the vegetarians, sir. Anyone vegetarian? Andrew? Okay. The fact is, we might just think of us as so low down in the pecking order of intelligence that I think we can eat these creatures. And for God's sake, there's 7 billion of us. You're looking very sad, Nicola. Okay, so there we are. And we've got a picture. We're, by the way, if there's any aliens here, we're from the third rock from the sun. This is how we try to communicate. This is a Russian telescope. We sent this message off to Hercules cluster or whatnot a long time ago. And let's go back, sorry, just go back. Here we are. It sent it, so the Arecibo one sent it to the globular cluster, that's 25,000. Well, you're not going to get any answers. I mean, it'll take a year to decipher English, as this lady kindly said, they speak English. So it'll take about a year to actually learn that language. But we've also sent messages to Andromeda Galaxy, Cassiopeia, the W that you can see, Cygnus the Swan in summer, Orion and Cancer. And I personally sent a message to Orion. I had, when I was 11, a little torch from my father, who was in the army, and I went like this. Let's see if you can decipher this. Anyone here interested in Morse, right? Ready? Oh, I'll do this. What? Anyone get that one? Yes? SOS, save our sausages. Yeah. Save our souls. So now, if you know Orion, it has a belt, and those stars are 1,500 light years away. So don't expect anything in the next, I can't work it out, 3,000 minus 40. 2,960 years. But they will be here if they can travel at the speed of light. So, we've got the Russian telescope. Some people have said to me, have they already landed? Now, no one's actually come up with this idea, and I think I'll patent this idea. Okay. You need a lot of energy to go to the moon. Who's seen Saturn V take off? 1, 2. I haven't. But I've heard the noise, I've heard what it sounds like, and you get the rumble through the ground because the speed of sound is stronger faster in a solid like the Earth. If you've got a huge spacecraft of 500 tons with this man on board, right, you're all by yourself, sorry about that, or you can bring your wife as well. Okay, and you try to get up close to the speed of light, it will take 10 to the power 20 joules. And that's so much, that's like the United Kingdom's entire network of 100 gigawatt power stations working for 30 years flat out to give him the energy to go to the nearest stars. It's like when we went to America and, say, the native Indians of America looked out and they saw the Mayflower. I mean, they had canoes, and you had these dirty, great big ships, and then you have the conquistadors with their gunpowder. I mean, you've never seen guns before, and they start shooting. And then they bring diseases as well. Yeah. Oh, why? Terrible, isn't it? Terrible. Anyway, Professor Stephen Hawkins says we shouldn't speak to the aliens. Anyone agree?
Be careful what you wish for.
Okay, 1, 2. Anyone disagree with Professor Hawkins? I'll get your names later. Ella, what do you think? And here's the last slide. Well, no, this is the second last slide. That has enough energy to go to the moon and come back. That is the amount of energy in the first atomic bomb. So 10 to the 20 will be 10 million of those to get this man and his wife to the nearest star. Oh, by the way, you know you get up to the speed of light, or 5% or 10%. You know you have to slow down, don't you? So you have to turn around and fire rockets for another year to slow down. Otherwise you just go whizzing past. So, there we are. How do you feel if tomorrow we wake up and we find that we are not alone, in our universe. And it's over to you. Thank you very much. First person, sir.
You talked about detecting planets as they go around this way. How about the ones that are at 90 degrees?
No, absolutely right. We're talking a line of sight. So when you're talking of a line of sight, you have to multiply this by a large number. And I've seen in the literature there might be 100 or 200 billion planets. So there might only be 17 billion Earth-like planets, but the Jupiters, the funny ocean seas, all those types of planets, there might be 100 or 200 billion. So there's 100 billion stars, and there might be an equal number of planets, or double, or triple. But there's 17 billion Earth-like planets. And some of them will be in the Goldilocks zone. Thank you very much, sir. Next, yes, madam.
It's not just the planets in the Goldilocks zone, but also some of the moons in the outer solar system.
Excellent. Excellent. They have discovered, Enceladus, Triton, that there are certain moons that go around Jupiter, Saturn, etc., that they have actually detected water. So if you've got volcanic action warming up this body of water, you could have liquid water. I think the prime thing is to have liquid water and an energy source. And if it's warm enough, I have a colleague called Rosalie Lopez, and she was one of the first to discover the volcanoes on Io. Well, there's all this tidal friction going on inside these satellites, and it really heats up the sulfur, and you get this sulfur and brimstone coming out. Well, if you can heat the water up to past 0 degrees, or whatever the melting point is out there, yeah, you could have whales. You could have intelligent whales. Next question. Don't be frightened, you're on video, don't worry. Yes?
How do you determine the fraction of life-bearing planets that are on the planet?
How do you determine how many of the life-bearing planets will eventually do intelligent life? That, I suspect, is the most difficult. If I can just quote Francisco Diego from University College London, I'm not an astrobiologist, obviously there are degrees in this area of astronomy and biology brought together. But is it the case that our Earth's axis has been fairly constant? And don't you need a little body like the Moon, an 81th of the mass of the Earth? Not every planet has a beautiful moon like our Moon. So if you start messing around with the climate of the Earth, faster than a few million years, so we don't have a moon to keep our Earth in a certain position, then the climate will change dramatically over many thousands of years. Now, I know the last ice age just finished about, what, 10,000 years ago, but when I look at graphs, it was either ice age or not an ice age, it's -2, it's 2 degrees hotter. But what happens if it's 50 degrees or -50? You get a little bit of life forming, and then wiped out. A little bit of life forming. You know, 2 billion years we had bacteria changing the atmosphere. It must have been a fairly constant 2 billion years. Now, we had dinosaurs working for 150 million years. We would not have grown up. They had to be wiped out. They had to get the asteroid smack in Mexico and wipe them out. And then there was these furry creatures, what are they called, mammals or something? And we grew up, 65 million years later we grew up. And then, even then, we were nearly wiped out. 70,000 years ago, was it Mount Toba in Indonesia? Nearly wiped out the whole of human civilization. We can be wiped out at any time. Look at, is it Chernobyl? Who's from Russia again? Chernobyl? What was that place? No, they're from Russia. Chernobyl. Yes. And that was the size of a London double-decker bus. And that hurt 1,500 people. But what happens if it hits a city? And what happens when you get the 1 kilometre body hitting a city? So, yes, it is fascinating, but I think we're just darn lucky. But you can always factor in something. I'll give you this as an example. You've got, 100 billion planets and there's 70. But you could say that the chances of all these Earth-like planets having life is, 10 billion to 1. But then there's us. But then I say, but there are 100 billion galaxies.
Yeah.
You see? Anyway, shall we do that poll again, just for a bit of fun? Would you like that? Who thinks there's some form of life somewhere in our galaxy? Who thinks not? Oh, there's still about 6 or 7. Who thinks we are unique in the whole universe?
But not necessarily mean human life. It could be anything.
Oh no, but I want intelligent life. I want a dolphin. I want a whale.
Politicians are...
I want a politician. I want David Cameron. Nick Clegg. I don't know. The fact is, our brains are enormous, aren't they? And I'm looking at you, and I remember doing a project 30 years ago, which you look at the stars from a very large telescope, and you digitize it. You turn all that into noughts and ones. And I said to my supervisor, I'll write something that can distinguish between the different galaxies. And he said, David, we can't even distinguish between stars and galaxies. Our brain is able to absorb huge amounts of information. And is there a single computer that is as intelligent as a 5-year-old child? And all right, one day they might produce one. But we are fantastic. We've gone from Galileo. Before Galileo, we thought everything went around the Earth. Then he said, no, we went around the sun. He showed the telescope, shows 30,000 plus stars in the Milky Way. We measured the Milky Way in the 1900s. We found out from Edwin Hubble and Henry Leavitt Swan that the galaxies are moving away from us. And in 1965, we saw the Big Bang's relic radiation. And we're looking to find out what dark matter is and what dark energy is. And the brain could fit in the palm of your hand. You just think about us. Yes, madam, at the back.
You include string theory in your
I haven't done astronomy since 1978. I know absolutely nothing about string theory, except I think there are little strings which make protons look big. And you can pluck them like little harps. But I know, honestly, I know nothing about this. You'd have to speak to some eminent professor. Right at the very back.
Hi. There's a theory on the formation of life on asteroids within our solar system. So is there any research focused on finding life not even on planets or moons? But
Oh, you want them on asteroids?
yeah.
Well, listen.
Not life exactly, but like molecules, like amino asteroids. Something like that.
Yes, because if you take Fred Hoyle's, was it called The Black Cloud, or all the lovely science fiction ideas that he had, plus his own ideas that we may have come from, comets bombarding us with amino acids. I believe, because I'm not a biologist, there are 20 famous amino acids. By the way, you get most of them from eggs, so you must eat eggs. So the fact is that we could have been bombarded by comets. Now we believe that all the water in the oceans came from comets, so why don't we have the precursors to life itself? What about asteroids? Yes, I'm sure we're visiting an asteroid, aren't we? Ceres, and we're visiting other asteroids. And I suppose one day we'll actually pick up some stuff and bring it back, and as long as we don't contaminate it, we can start looking at that. And also there must be a lot of gold and iron ore and platinum, and I'm sure a banker will make an awful lot of money from asteroids. So thank you for that. There's another hand up there, sir.
Yes. I was wondering if your comment about people who say they've seen aliens or been abducted by aliens, and there are some organisations whose leaders say that they've got messages from aliens and they started up an organisation to propagate.
Very sound people, extremely sound people. I've got, you don't know this, so that I've got fairies at the bottom of my garden. And the only trouble is they'll only come out for me. They won't come out for you. Yeah. It's really sad. I think when they landed on the moon, and there's that beautiful picture of Earthrise, Apollo 8's Earthrise, I think we've got to realise just how wonderful we are. I mean, to hit the moon after 384,000 kilometres and land 2 people with poor Michael Collins going around wondering what to do. Perhaps he had Sudoku or but yeah, I think we just have to just say sadness. I mean, UFOs exist, yeah, unidentified flying object. There are, as Patrick Moore would have said, things that people don't know what they were. But if it was 10 to the 20 joules landing in my back garden, I would know about it. And then they say, take me to your leader. Well, actually, it's Obama. It's David Cameron. It's not me. And that's it. Darren, have you got anything to say? Darren's from Kazakhstan. You might know that the Russians used to send their spacemen from Baikonur. Is that right? Baikonur. It's a lovely name, that one. I was just researching recently, because I'm giving another talk tonight. You can go to the Women's Institute, Fannington, without, near Canterbury, and I'm doing 56 years of space travel. And Alexei Leonov was the first person in space to do the spacewalk. And his father, can you imagine, say, what is Alexei doing out there? It's a man. And you know what? He nearly died. It's such a sad story, and we must find out about it. But after 10 minutes, he wanted to get back in and found that his shoes weren't fitting properly, and he couldn't get into the airlock, and it was touch and go. It was really touch and go. But yes, just floating around in space, that must be wonderful. And I personally think our only chance is to have bases on Mars, bases on the Moon. So if you have a fight, all right, you wipe yourself out, you carry on. Then you will build a spacecraft. But the thing that most astronomers are worried about is something called the Fermi paradox. Fermi paradox. Anyone heard of Fermi paradox? No? You haven't heard of Fermi? You are the RAS friends. You are the RAS friends. Yeah, okay, Fermi, or Enrico Fermi, one of the greatest scientists of all time, posed the question, why haven't they already visited us? Because you can do the mathematics. You build a spacecraft which will land on a planet, and there is iron ore, platinum, you name it. They then build 5 more rockets, who then go out to places. They land, and they build 5 more. It would take 700 million years to see every planet in the galaxy. And our galaxy is more than 10 billion years old. Where are they? And I notice the big hand is just about to reach 12. So we will have one more question, and then it's the end. Oh, yes, sir.
Should do the drink equation, as long as we don't wipe ourselves out,
yes,
because of our pioneering spirit, we will see the galaxy.
Oh, so you're thinking we're at the moment unique, sir?
Yeah.
And in the next million years, we will go to boldly go where no womankind and mankind has ever gone before.
Yes.
And is that funny woman with the thing in their ear? What's the name of Huru? Which I think means peace or something in Kenyan. Peace. Freedom. I once was in Moscow. This was in the communist era. And there was this thing which is called Pravda. And you put, because some people are so poor they couldn't even afford the newspaper, so you'd have the free newspaper up on the wall, but there was no Pravda. And Pravda means truth, so I wrote underneath, no truth today. Cut that out, Andrew. Remember, we have a worldwide audience. And America, oh, we're having fun. Right, we'll have one more question and then we'll call it today. Oh, was that the question?
I mean, I think we'll see the
galaxy. You think you will? All right, hands up those who think we will see the universe. Yes! Yes!
There's money in it.
There's bankers! Well, thank you very much. You've been a great audience. Thank you very much.